two dice are rolled together, find the probability of getting a total of at least 10, a total of at most 4, a multiple of 2 on one die and an odd number on the other die. So this is the question. So this question we are going to identify the probability when we are going to roll two dice at a time. Dice, it's nothing but a cubical object. Okay, it will be having 6 faces. On each of its face we will be having the numbers from 1 to 6. That is, each face will be numbered as 1, 2, 3, 4, 5 and 6. Okay, so when we are rolling a single die, okay, the maximum possibilities will be 1, 2, 3, 4, 5 or 6. Okay, but here we are rolling two dice at a time. So we will be having various possibilities. For example, if the first die is going to show 3 on its face, the second die might show 4 or it might show 5, 6, anything. We don't know about that. So first thing is we need to write all the possible outcomes when we are rolling these two dice. Okay. So as we all know, when we roll a single die, okay, the maximum possibilities is, that is the number of possible outcomes, it is 6. Same way, when we are rolling two dice at a time, the number of possible outcomes will be 6 power 2. That is, we will be having 36 possible outcomes. See, n of s is equal to 6 when we are rolling a single die. 6 power 1, 6. When we are going to roll two dice at a time, it will be 6 power 2, which is 36. Okay, so let's write the sample space and check whether we are getting all the 36 possible outcomes. Let's check. So sample space S is equal to set of all. This is easy writing, children. Let's start. If the first die is going to show 1 constantly, okay, 1. So the second die might show 1, 1 comma 1. So 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. That is, the first die will be showing 1, okay, so that the second die might show 1, 2, 3, 4, 5 or 6. The first subscript shows the first die and the second subscript shows the number relating to the second die. Okay, so now next, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. That is, the first die will be showing 2, whereas the second die might show 1, 2, 3, 4, 5 or 6. Next, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. Likewise, we have written all the possibilities. Now just count and see. We will be definitely having 36 possibilities. Okay, 6 in the row, 6 in the column. So totally we are having 36 possibilities. So these are all the possible outcomes which we get when we are going to roll two dice at a time. Okay, now the first question, the probability of getting a total of at least 10. So total of at least 10. The meaning of at least in the probability is minimum we should get a total of 10. Maximum, how much ever is going to be the total, everything we are going to take. So at least means in probability from that particular number which is mentioned, okay, to the number maximum which is available in the lot. Okay, so at least 10 in the sense, so we will be choosing the lot where we are getting 10 as its sum. Okay, then if we get 11, if we get 12, if we get 13, 14, 15, everything we can take it under this. Okay, so probability of getting at least 10 in the sense, minimum you should get a total of 10, maximum how much ever higher the total is going to be, everything you can take it under count. Okay, so at least 10. So let's see which are all the possibilities. So minimum 10. So can you see 4 comma 6, 6 plus 4 it is 10. 5 comma 5, 5 plus 5 is 10. 6 comma 4 where 6 plus 4 is again 10. So these are the possibilities where we get 10. Okay. Next 5 comma 6. Here 5 plus 6 is 11. So we can include that also. 6 comma 5 which is the total of 11 which also we can include. 6 comma 6 where the total is 12, so that also we can include. Okay, so these are the 6 possibilities where we are getting a total of at least 10. Okay, that is minimum you are getting a total of 10. Okay, apart from that we are getting total of 11, we are getting total of 12, that also we are including in the favorable outcomes. Okay, hope you are able to understand. At least 10 in the sense from 10 to the maximum how much ever total we are getting, everything we can include. Okay, that's it. So let's write the first question. Let's write the event, that is the favorable outcomes. What are they? They are 4 comma 6, 6 comma 4, 5 comma 5 where we are getting the total of 10. Then 5 comma 6, 6 comma 5 where we are getting the total of 11. Then 6 comma 6 where we are getting the total of 12. So the probability of the event, that is the event of getting a total of at least 10. Okay, number of favorable outcomes 6 by total number of outcomes 36, that is 6 1 times 6, 6 6 are 36. That's it. Okay, now the second subdivision, a total of at most 4. Now we are going to discuss about the keyword at most in probability. At most in the sense maximum the total should be 4. Okay, that is the highest number. Okay, so minimum you can have it as some 0, 1, 2 and 3, all the totals which are lesser than 4 also you can include. So what is meant by utmost here? Maximum itself the total should be 4. Okay, minimum whatever is going to be the total, it could be 3, 2, 1, it could be 0, even that also we can include it in the count. So now you people will be able to understand the difference between at least and utmost. So at least in the sense from 10 to the maximum possibilities, whatever is going to be the total. At most 4 in the sense that is you are going to bring it in the descending order. 4 is going to be the highest number. Okay, lesser than 4 all the counts we will be including here. So at least means minimum 10, maximum anything. Same way, at most 4 in the sense maximum itself is 4. Okay, minimum whatever is lesser than 4 everything you can include. Okay, so let's write the event. The event of getting the probability of at most 4 as the total. Okay, so 1 comma 1 the total is 2, 1 comma 2 the total is 3, 1 comma 3 the total is 4. Okay, 1 comma 4 what happens, the total becomes 5, it becomes greater than 5, so greater than 4, so we are not including this. Okay, now come down, 2 comma 1 where the total is 3, so we can include. 2 comma 2 what happens there also the total is 4, so we can include. 2 comma 3 the total becomes 5 here children, it is greater than the 4 which we want, so we are not going to include this. Next 3 comma 1, what is 3 comma 1? 4 again. 3 comma 2 it becomes 5 which is greater than 4 which we need, so that's it. So we are having 6 possibilities here. So the probability of the event of getting a total of at most 4. We are having number of favorable outcomes 6 by total number of outcomes 36. That is 1 by 6. That's it. Okay. Now third question. A multiple of 2 on one die and an odd number on the other die. So multiple of 2. 2, 4, 6, 8, 10, all these are multiples of 2. So 2, 4, 6. Let's consider these 3 rows alone. Okay, 2, 4 and 6. Because here the first die is going to have the even numbers, that is multiple of 2 on one die. So we are going to consider this. Next, an odd number on the other die. So odd numbers are 1, 3, 5 like that. No. So we are having this odd number 2, comma 1, 4, comma 1, 6, comma 1. Then odd number 2, comma 3, 4, comma 3, 6, comma 3. Next odd number 2, comma 5, 4, comma 5, 6, comma 5. That's it. So how much possibilities we are having here? 9 possibilities we have. So let's write the event. The event of having an even number on one die and an odd number on the other die. So even numbers 2, comma 1, 2, comma 3, 2, comma 5, where the odd number is in the second die and the even number 2 we are having it on the first die. Next 4, comma 1, 4, comma 3, 4, comma 5. Same way 6, comma 1, 6, comma 3, 6, comma 5. How much possibilities? 9 possibilities we have. So the probability of the event of getting a multiple of 2 on one die and an odd number on the other die. Okay, number of favorable outcomes 9. By total number of possible outcomes 36, which is 1 by 4. That's it. Hope you all understood. Thank you.